In Chapter 11, we're going to focus on the idea of finding areas of different kinds of shapes, and there are lots of different types of approaches. They mostly come back to the same basic concepts that we've been learning in the last couple of chapters. So if we can kind of understand the basic concept of area, we can move forward from there. The first really important thing to understand when you're dealing with area is what area really is, okay? If I ask you for the area of my classroom, for example, you would probably tell me the classroom is a certain number of square feet or a certain number of square yards in area, okay? What that really means, if you think about my classroom floor, for example, the classroom floor has tiles on it, okay? Each of those tiles is a 1 by 1 foot square, okay? When you're talking about a number of square units in a shape, what you're saying is, if you gridded that shape off into squares, how many total squares, how many 1 by 1 unit squares would fit into that region? Now, some shapes, that's a pretty basic, pretty straightforward concept. For example, rectangles and squares. It's really easy to count up the number of square units. It's not so easy if you're dealing with, say, a trapezoid or a circle or some kind of strange shape like an octagon or a decagon or something like that. So we're going to kind of build a couple of different strategies that will kind of move toward that. Now, rectangles and squares, okay? Let's say I've got a 3 by 4 rectangle, okay? You probably know some kind of formula for the area of a rectangle, okay? But I want you to understand why that formula works, okay? What we're really saying here is, this is 3 units high, this is 4 units high, okay? If I grid this off, I could grid it into 3 squares going this way, and I could grid it into 4 squares, maybe not drawn to scale, but 4 squares going that way. Okay, horribly drawn picture, but I think you get the idea. So here's the point. There are 4 stacks of 3 squares each. And again, they really should be the same size, but hopefully you can kind of picture that. Okay, if I have 4 stacks of 3 squares each, how would I find the area? Well, I have 4 stacks of 3. 4 times 3 is equal to 12 square units. Okay, if you count the square blocks in here, there should be 12 of those. Okay, if I grid it off, 12 total squares. Okay, so some of you have learned that the area of a rectangle is the length times width. I prefer to think of it as the length of the base times the height. Okay, how many squares can I put across the base? How high can I stack each of those? Okay, so area of a rectangle, you can think of it as being the length of the base times the height. Again, if you want to think of it as length times width, same thing. Okay? Now the follow-up from there. You're going to be given all kinds of different shapes, and you're going to be asked to find different areas. For example, I could have a rectangular garden, okay, that has a 2-foot wide path around it, okay? And maybe I want you to find the area of the pathway, okay? That whole rectangle has a certain number of squares in it. If I want to find the area of the pathway, I want to remove the squares for the garden, okay? So I really need to figure out the area of the outer rectangle, okay? And I want to subtract the area of the inner rectangle. Okay, now I have to figure out the dimensions of that inner rectangle. If this walkway is 2 feet wide, I've got a length of 2 feet there, I've got a width of 2 feet there, okay? Whole length here is 10. I'm taking off 2 on this end, I'm taking off 2 on that end. That's only going to leave me with 6 feet for that whole length along there, okay? Now, going the other direction, vertically, the whole height's 8, that width there is 2, that width there is also 2, okay? If I take those 2 2's away from 8, that leaves me with 4. So that is a 4 by 6 rectangle on the inside. 4 times 6 is 24. The outer rectangle is an 8 by 10, okay? So if I take the outer area, 8 times 10 is 80. That's telling me there would be 80 squares if I gridded that thing off. And I want to remove the inner area, okay? The inner area would have 24 squares if I gridded that out, okay? And if you subtract those 2, I think that's 56 square units, okay? You could write units squared or square units if you want to write out the words, okay? That's the basic idea there. So you can basically cut out and remove those square units from the overall rectangle, All right? Now, your book has a couple of examples here. They call this the divide and conquer method. There are a few different ways you can do it. So you'll have irregular shapes, and irregular shapes, I don't know a formula for the area of that thing, okay? But I can try to break it up into shapes that I do know how to find the area of. And moving forward, we'll know how to find areas of rectangles and trapezoids and circles and all kinds of other things. Right now, we're really just focusing on rectangles, squares, those kinds of things. So one approach here would be to try to break this up into rectangles. And by the way, the directions will tell you that these are all right angles in these shapes. They're not going to try to trick you in this section having things that aren't actually right angles. Okay, so one approach would be to kind of try to break this thing up into a bunch of rectangles. And so I could make a rectangle there. It's a 2 by 6 rectangle. That area is going to be 12. Okay, I could make another rectangle here. Okay, this whole length here is 7. Okay, this length here is 2. So if I take this 2 away from 7, that's going to leave me with a length of 5 right here, okay? The height of this whole thing, I've got 2 vertical units here, and I've got 6 vertical units there. So the whole height of this thing is going to end up being 8. So this is a 5 by 8 rectangle. It has an area of 40 square units, okay? Then we've got another rectangle that I could create here, okay? And this can sometimes get a little bit tricky. All right, so this width here is 2, so we know that. I need the height going this direction, okay? I know the whole height here, I've got a 6 plus a 2, which is an 8, okay? This height here is 5, so it's not drawn to scale, but that's gonna leave me with 3 right there. So this is a 2 by 3, and that area is going to be 6. And then this final rectangle, the entire height here matches up with that 2 and that 6. The entire height is 8, and it's got a width of 3, so we get 24. So 24 square units if we gridded this off, plus 6 is 30, plus 40 is 70, plus 12 is 82 square units, or we can say units squared if you want to write it that way. Okay? Now, you can do that totally differently. Okay? Somebody else might look at this shape and say, you know what? I could just box this in, and I could make this whole thing into a big rectangle. Okay? And that width there was 2, that length there was 6. So the whole height of this thing is going to be 2 plus 6, which is 8. Okay? And then they could look at the width going this way. They could say, well, the base of this thing has a length of 7, plus a length of 2, plus a length of 3. Okay, that's a length of 12. Okay, so 12 times 8 is 96 square units for that whole rectangle. Okay, but I'm cutting out the square units here. And that's a 2 by 2 square coming from the original. That's 4 square units that we're removing from the 96. Okay, 2 by 5, that's a 10 square unit rectangle right there. So I'm taking 96, I'm taking away 10, I'm taking away 4, and that's going to leave me with 82 square units as my final answer. So again, you can break your shape up into other shapes that you know how to find the areas of, and that'll help you find the area of irregular shapes.